Hello students, in today's class we will discuss about mole concept and molar masses, percentage combination and stoichiometry and stoichiometric calculations. We will also answer some of the multiple choice questions. As you know, in the class of chemistry we follow NCERT syllabus rationalized for the year 2023 and 24. All the points discussed in this session are important. Please note down and make your own notes. I welcome you once again. Mole concept and molar masses. Atoms and molecules are extremely small in size and their numbers in even a small amount of any substance is large. That means they are small in size but very large in number. To handle such large numbers, a unit of convenient magnitude is required. Just as we denote 1 dozen for 12 items, we use the idea of mole to count entities at the microscopic level. These entities may be atoms, molecules, particles, electrons, ions, etc. 1 mole of substance is the amount of substance that contains as many particles or entities as there are atoms in exactly 12 grams of 12C, that is 6.023 into 10 to the power of 23 atoms per mole. In order to determine this number precisely, the mass of a carbon 12 atom was determined by a mass spectrometer and found to be equal to 1.992648 into 10 to the power of minus 23 grams. That is, first we determine the mass of carbon 12 atom using a mass spectrometer, and that value is equal to 1.992648 into 10 to the power of minus 23 grams. Therefore, 1 mole of carbon weighs 12 grams. The number of atoms in it is equal to 6.0221237 into 10 to the power of 23 atoms per mole. The idea of mole is used to count entities at the microscopic level. In SI system, mole was introduced, mole or with symbol mol, MOL, was introduced as the 7th base unit for the amount of substance. The amount of substance, that is symbol N, small m, of a substance is a measure of number of specified elementary entities. An elementary entity may be an atom, a molecule, an ion, an electron, any other particle or specified group of particles. It may be emphasized that the mole of a substance always contains the same number of entities, no matter what the substance may be. So, the mole of a substance always contains the same number of entities, no matter what the substance may be. This number of entities in 1 mole is known as Avogadro constant or Avogadro number, denoted by letter Na in honor of the scientist Amedeo Avogadro. To appreciate the largeness of this number, it is written using without any powers of 10. So this number is shown on the screen. please count the number of zeros and write down the number. Hence, so many entities, that is so many atoms or so many molecules or any other particle, constitute 1 mole of a particular substance. Thus, in the case of one hydrogen atom, 1 mole is equal to 6.022 into 10 to the power of 23 atoms. So, here underline for hydrogen, it is written in atoms. Similarly, if you want to measure the number of molecules in 1 mole of water, it is 6.022 into 10 to the power of 23. The number is same, and so it will be molecules, water molecules, not atoms. So 1 mole of sodium chloride will be 6.022 into 10 to the power of 23 formula units, that is sodium chloride, formula units of sodium chloride. Molar mass. Having defined the mole, it is easier to know the mass of 1 mole of a substance or the constituent entities. Thus, the mass of 1 mole of a substance in grams is called its molar mass. The molar mass in grams is numerically equal to the atomic oblique molecular or formula mass in U. Therefore, the molar mass of water is equal to 18.02 grams per mole. You have to remember that. Similarly, the molar mass of sodium chloride equals 58.5 grams per mole. Now, let us solve one problem. Calculate the molecular mass of glucose C6H12O6 molecule. Solution. The molecular mass of glucose, whose empirical formula is C6H12O6. So, we have to take the 6 molecules, 6 into the mass of carbon molecule is 12.011 U, plus there are 12 hydrogen molecules, so 12 into 1.008 U, and 6 oxygen molecules will have a mass of 6 into 16.00 U. So simplifying and adding, we get the value as 180.162 U. Next, we will take up percentage composition. So far, we are dealing with the number of entities present in a given sample. But many a time, information regarding the percentage of a particular element present in a compound is required. Suppose an unknown or a new compound is given to us. The first question will be, what is its formula or what are its constituents and in what ratio they are present in the given compound. For known compounds also, such information provides a check whether the given sample contains the same percentage of elements as present in a pure sample. In other words, one can check the purity of a given sample by analyzing this data. So, mass percentage of an element will be equal to the mass of that element in compound divided by molar mass of the compound into 100. Let us take two examples. Mass percentage of H2O. Water contains hydrogen and oxygen. The percentage composition of both these elements can be calculated as given below. So, molar mass of water, we know that it is 18.02 grams. Molar mass percentage of hydrogen is 2 into 1.008 by 18.02. Here There are two molecules of hydrogen into its weight is 1.008. That is the molecular weight of hydrogen atom is 1.008 divided by the total mass of water is 18.02 grams. And since we are required to calculate percentage, we have to multiply it by 100. So therefore, the value simplifies to 11.18. Mass percentage of hydrogen is 11.18. Next, we will calculate mass percentage of oxygen. That is equal to 16.00. That is molecular weight of oxygen divided by the molar mass of water 18.02 into 100 because of percentage. So that works out to 88.79. Now let us take one more example. Percentage of carbon, hydrogen, oxygen in ethanol. The molecular formula of ethanol is C2H5OH as shown on the screen. Therefore, molar mass of ethanol is, that is 2 into mass of carbon, that is 2 into 12.01 plus there are 6 hydrogen atoms, here 5 and OH ka another H. So total 6 hydrogen compound, 6 into 1.008, that is mass of an hydrogen plus the oxygen, there is only one element and its mass is 16.00. So total mass works out to 46.068 grams as per the above calculation. So mass percentage of carbon. So that will be equal to 24. 2 into 12.01 is 24.02 divided by 46.068 into 100, that is equal to 52.14. Now next is mass percentage of hydrogen, that is equal to 6.048, that is 6 into 1.008 divided by 46.068, that is the molar mass of ethanol into 100, that is equal to 13.13%. So mass percent of hydrogen is 13.13. Next is mass percent of oxygen. So that will be equal to, there is only one molecule, hence it is 16 grams divided by 46.068 grams into 100, that is 34.73. After understanding the calculation of percent of mass, let us now see what information can be obtained from the percentage composition data. Empirical formula for molecular formula. An empirical formula represents the simplest whole number ratio of various atoms present in a compound, whereas the molecular formula shows the exact number of different types of atoms present in a molecule of a compound. If the mass percent of various elements present in a compound is known, its empirical formula can be determined. Molecular formula can further be obtained if molar mass is known. So molecular formula is equal to N into empirical formula. That is, empirical formula subscripts N, where N may be 1, 2, 3, etc. The molecular mass divided by empirical mass equals N. Next problem. A compound contains 4.07% hydrogen, 24.27% carbon and 71.65% of chlorine. Its molecular mass is given as 98.96 grams. What are its empirical and molecular formulae? So the percentage of hydrogen, carbon and chlorine is given. So the compound contains these three elements. We are required to calculate the empirical formula and molecular formula. So let us go step by step. There are about 5 steps which give details of calculating the molecular formula. The first step is conversion of mass percent to grams. Since we are having mass percent, it is convenient to use 100 grams of compound as the starting material. So let us assume the, the 100 grams of compound is given to us. Thus, in 100 grams, we have 4.07 per grams of hydrogen, 24.27 grams of carbon, and 71.65 grams of chlorine. That is, we are simply multiplying, removing this percentage side and writing it as grams. Step 2 is to convert the number of moles of such elements. For doing this, divide the mass obtained above by collective respective atomic masses of various elements. This gives the number of moles of constituent elements in the compound. Therefore, the moles of hydrogen equals 4.07 grams divided by 1.008 grams. That comes to 4.04. This is a ratio, hence there is no unit here. Similarly, moles of carbon will be 24.27, that is the given mass of carbon divided by its molecular mass, that is equal to 12.01 grams, that is equal to 2.021, that is the moles of carbon, number of moles of carbon. So moles of chlorine are 71.65 divided by 35.453 grams. That is, chlorine's mass of chlorine is 35.453. That is equal to 2.021. So from the above relationship, we can obtain the smallest number amongst them. It is the divide each mole values obtained above by the smallest number amongst them. The smallest number is 2.021. So dividing by each, we get the ratio as 2:1:1 for hydrogen, carbon and chlorine. That is H:C:"Cl. In case the ratios are not whole number, then they may be converted into whole number by multiplying by the suitable coefficient. Next step 4. Write down the empirical formula by mentioning the numbers after writing the symbols of the respective element. That is, we can write H2 is here, Cl. CH2Cl is the formula. CH2Cl is thus the empirical formula of the above compound. Step 5 is writing the molecular formula. So this can be written. Determine the empirical formula mass by adding the atomic mass of various atoms present in the empirical formula. For CH2Cl, empirical formula mass is 12.01 plus 2 into 1.002 plus 35.453. This is for carbon and 2 molecules of hydrogen plus mass of chlorine. If we add that, we will get 49.48 grams. That is empirical formula mass. So next we divide molar mass by empirical formula mass. So molar mass we have calculated as it is given as 98.96. divided by empirical formula mass as we have calculated in this step is 49.48. So 98.96 divided by 49.8 grams gives 2. That is therefore N is equal to 2. Multiply empirical formula by N obtained above to get the molecular formula. So empirical formula was CH2Cl with N is equal to 2. Therefore, the molecular formula is C2H4Cl2. Stoichiometry and stoichiometric calculations. The word stoichiometry is derived from two Greek words, stoichion meaning element and metron meaning measure. Stoichiometry thus deals with the calculation of masses, sometimes volumes also, of the reactants and products involved in the chemical reaction. Before we understand how to calculate the amounts of reactants required are the products produced in a chemical reaction, let us study what information is available from the balanced chemical reactions or the equation. Let us consider combustion of methane. A balanced equation for this reaction is given below. CH4, that is methane, plus 2O2 oxygen gives product CO2 plus 2H2O. Here methane and dioxygen are called reactants. That is, the left hand side is reactant and the right hand side is product, that is carbon dioxide plus water, 2H2O. This is water. So in this reaction all are oxygen and this is indicated by letter G in the brackets next to the formula. In case of solids or liquids, we can use the letter S for solid and L for liquid. The coefficient 2 for O2 in the reactants, that is on the left hand side, and 2 for H2O in the product on the right hand side are called stoichiometric coefficients. Similarly, the coefficient 1 for methane and carbon dioxide in each case. These represent the number of molecules and moles as well taking part in the reaction or formed in the reaction. Next, we will consider the above reaction and further make some calculations. Here, the previous equation CH4 methane plus 2O2 reactants gives product CO2 and 2H2O, all are in gaseous stage. So 1 mole of methane reacts with 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of H2O. 1 molecule of methane reacts with 2 molecules of oxygen to give 1 molecule of carbon dioxide and 2 molecules of H2O. That is, we can write it 22.7 liters of methane reacts with 45.4 liters of oxygen to give 22.7 liters of carbon dioxide and 45.4 liters of H2O gas. 16 grams of methane reacts with 2 into 32 grams of oxygen to give 44 grams of carbon dioxide and 2 into 18 grams of water. From these relationships, the given data can be interconverted as follows. So mass can be converted into moles and moles can be converted into number of molecules. From this, we can also calculate density. Density, that is mass over volume. Limiting reagent. Many a time, reactions are not carried out with the amounts of reactants that are different than amounts as required by the balanced chemical reaction. In such situations, one reactant is in more amount than the amount required by the balanced chemical equation. That means we are not conducting experiments with exact amount. Sometimes one reactant will be more and the other may be less. The reactant which is present in the least amount gets consumed after some time, and after that further reaction does not take place, whatever may be the amount of reactant. So I will repeat this. Many a times reactions are carried out with amounts of reactants that are different than the amounts as required by the balanced chemical reaction. In such situations, one reactant is in more amount than the amount required by the balanced chemical reaction. The reactant which is present in the least amount gets consumed after some time, and after that further reactions does not take place. Further reaction does not take place, whatever may be the amount of other reactant. Hence, the reactant which gets consumed first limits the amount of product formed and is therefore called the limiting reagent. In performing stoichiometric calculations, this aspect is kept in mind. Reactions in solutions. A majority of reactions in the laboratory are carried out in solutions. Therefore, it is important to understand as how the amount of substance is expressed when it is present in the solution. The concentration of a solution or amount of substance present in its given volume can be expressed in any of the following ways. That is, first one is mass percent or weight percent. That is written as W by W percentage. That is mass of solute divided by mass of solution into 100. The next one is volume percentage. Volume of solute divided by volume of solution. So mole fraction. Then the next one is mole fraction. That is equal to number of moles of solute divided by number of moles of solute plus number of moles of solvent. Molarity. So it is represented by symbol capital M. That is molarity equals number of moles of solute divided by volume of solution. Molality. In molality, the denominator is in kg. So, molality represented by the letter small m equals number of moles of solute divided by mass of solvent in kg. Let us study them in detail. Balancing a chemical equation. According to the law of conservation of mass, a balanced chemical equation has same number of atoms of each element on both sides, that is left hand side as well as right hand side of an equation. So let us take a reaction of a few metals and non-metals with oxygen to give oxides. So here on the screen you will see 4 Fe plus 3 O2 plus gives 2Fe2O3. So Fe on the left hand side is in solid state and the middle term oxygen is gaseous state, whereas the product on the right hand side is solid state. So if you compare the number of molecules on the left hand side, it is equal to the number of molecules in the right hand side, that is consider Fe. 4Fe has got on the left hand side 2Fe2, 2 into 2 becomes 4Fe on the right hand side. Similarly, in the case of oxygen, 3O2, that is 6O oxygen, and in the right hand side also 2 into O3. Hence, it is a balanced equation. In A and B, in terms A and B are balanced since there are same number of metals and oxygen terms on each side of the equation. Now we will consider another unbalanced equation. So here phosphorus atoms are balanced out but not the oxygen atoms. So phosphorus P is the symbol of phosphorus, P4 on the left side, P4 on the right hand side, and phosphorus is balanced. Whereas oxygen has got 2 on the left hand side and oxygen whereas it is oxygen atoms are 10 in the right hand side. Hence it is not balanced. To balance it, we must place coefficient 5 on the left hand side of the oxygen, left of oxygen on the left side of the equation to balance the oxygen atoms appearing on the right hand side. Therefore, when you balance it, the equation becomes after balancing P4S, P4 plus 5O2 and the product is P4O10. So there are 4 atoms of phosphorus on the left side as well as right hand side, and similarly 5 into O2 on the left hand side of the equation and 10 O10 on the right hand side. Hence this is a balanced equation. Now we will take another example of combustion of propane. The formula for propane is C3H8. This equation can be balanced. So we'll write the equation. So write down the correct formula and reaction. So the reaction is C3H8 plus O2 gives a product of carbon dioxide plus H2O. So here propane is C3H8 and oxygen as it is, and it gives carbon dioxide plus H2O. So first step will be to balance the number of C atoms, carbon atoms. Since 3 carbon atoms are in the reactant on the left hand side, therefore 3 carbon dioxide have to be there, and hence we will write it, revise the empirical formula. C3H8 plus O2 gives 3CO2 because 3 carbon atoms on the left hand side, we have to write 3CO2 plus H2O. Here please note propane is gas, oxygen is gas, carbon dioxide is gas, but water is in liquid state. It is written in bracket L. That next step will be balance the number of hydrogen atoms. On the left hand side, there are 8 hydrogen atoms. Please note here 8 hydrogen atoms in the reactants, and each molecule of water has 2 hydrogen atoms. See here, each molecule of water has 2 hydrogen atoms. So this will become, we have to get 4 molecules of water will be required for 8 hydrogen atoms on the right hand side. So we'll write it as 4H2O. Then next step is balance the number of oxygen atoms. There are 10 oxygen atoms on the right hand side. That is 3 into 2 equals 6 in carbon dioxide and 4 into 4 in water, whereas oxygen atoms are 10. Therefore, 5 O2 molecules are needed to supply the required 10 CO2 and 4 into 1, that is 4 in water. Therefore, 5 oxygen molecules are needed to supply the required 10 oxygen atoms. So, we will write the equation as C3H8 plus 5O2 gives 3CO2 plus 4H2O. That the last and final step is verify that the number of atoms of each element is balanced in the final equation. The equation shows 3 carbon atoms, 8 hydrogen atoms and 10 oxygen atoms on each side. All equations that have correct formulas for all reactants and products can be balanced. Always remember that the subscripts in formulas of reactants and products cannot be changed to balance the equation. Worked examples. Now we will solve problems, numerical problems of the sections mole concept and molar masses, percentage composition, and stoichiometry and stoichiometric calculations. Problem number 3. Calculate the amount of water produced by combustion of 16 grams of methane. Please read the question once again and let us start. The balanced equation for the combustion of methane is given by CH4 plus 2O2, that is oxygen combines with methane to form carbon dioxide and water. So the chemical equation is CH4 plus 2O2 gives CO2 plus 2H2O. Point number 1 is 16 gram of methane corresponds to 1 mole. From this, the above equation, 1 mole of methane gives 2 mole of H2O and 2 mole of water equals 2 into 2 plus 16, that is 2 into 18, that's equal to 36 grams, and 1 mole hydrogen equals 18 gram H2O, that is equal to 18 gram of H2O divided by 1 mole of H2O. Hence 2 mole into H2O into 18 gram H2O divided by 1 mole H2O equals 2 into 18 gram H2O, that's equal to 36 gram H2O. So we have thus calculated the amount of water produced by combustion of 16 gram of methane. Next problem. How many moles of methane are required to produce 22 grams of CO2 after combustion? Please read the question once again. We will start the solution. According to the chemical equation is CH4 combines with 2O2 to give CO2 plus 2H2O, that is 44 gram CO2 is obtained from 16 gram of methane. Please note that all the components are in gaseous form. Therefore, 1 mole carbon dioxide is obtained from 1 mole of CH4. Number of moles of carbon dioxide, that's equal to 22 gram of carbon dioxide into 1 mole CO2 divided by 44 gram CO2. The letter G in brackets indicates the state, that is gaseous state. That's equal to 0.5 mole carbon dioxide. Hence 0.5 mole CO2 would be obtained from 0.5 mole methane, or 0.5 mole of methane would be required to produce 22 grams of CO2. Next question. 50 kg of nitrogen and 10 kg of hydrogen, both in gaseous stage, are mixed to produce NH3 gas. Calculate the amount of NH3 formed. Identify the limiting reagent in the production of NH3 in this situation. Please read the question once again and we will solve. So the balanced equation for the above reaction is written as N2 combines with 3 molecules of H2 to give 2 NH3. All the three, that is nitrogen, hydrogen and NH3, are in gaseous stage. And this reaction can form in both ways. Now first we will calculate the moles. Number of moles of nitrogen equals 50 kg into N2 multiplied by 1000 grams of N2 divided by 1 kg nitrogen multiplied by 1 mole of N2 divided by 28.0 grams of N2. Simplifying, we get this value as 17.86 into 10 square mole. Again, number of moles of hydrogen equals 10 kg of hydrogen multiplied by 1000 gram of H2 divided by 1 kg H2 multiplied by 1 mole of hydrogen divided by 2.016 gram of nitrogen. Simplifying, we get the answer as 4.96 into 10 to the power of 3 moles. So that is the number of moles of hydrogen. According to the above equation that is given above, 1 mole of nitrogen requires 3 moles of hydrogen for the reaction. Both are in gaseous stage. Hence, for 17.86 into 10 to the power of 2 mole of nitrogen, the moles of hydrogen required would be 17.86 multiplied by 10 square mole of nitrogen multiplied by 3 moles of hydrogen gas divided by 1 mole nitrogen gas. Simplifying, we get the answer as 5.36 into 10 to the power of 3 moles of hydrogen. If you examine that, we have only 4.96 into 10 to the power of 3 moles of hydrogen. Hence, the dihydrogen is the limiting reagent in this case. So, NH3 would be formed only from that amount of available dihydrogen, that is 4.96 into 10 to the power of 3 mole. Since 3 mole hydrogen gives 2 moles of NH3, we can calculate the total requirement, that is 4.96 into 10 to the power of 3 moles of hydrogen into 2 mole ammonia NH3 divided by 3 mole H2. That is equal to 3.30 into 10 to the power of 3 moles of NH3. Thus, 3.3 into 10 to the power of 3 mole NH3 is obtained. If they are to be converted into grams, it is done as follows. 1 mole NH3 equals 17 gram NH3. That is 3.30 into 10 cube mole NH3 into, that is multiplied by 17.0 gram NH3 divided by 1 mole NH3. Simplifying, we get 3.30 into 10 to the power of 3 into 17 grams NH3. Therefore, that becomes, simplifying, 56.1 into 10 cube grams of NH3. That is equal to 56.1 kg of NH3. Hence, we have identified the limiting reagent in the production of NH3 in this situation. Also, we have calculated the amount of NH3. Now, we will take the next problem. A solution is prepared by adding 2 grams of substance A to 18 grams of water. Calculate the mass percent of solute. Please read the question again and we will proceed with the solution. Mass percent of A equals mass of A divided by mass of solution into 100. So the mass of substance is A. It is given in the question itself. That can be written as 2 grams, that is mass of A is given as 2 grams divided by 2 grams of A plus 18 grams of water. Because it is a percentage, mass percentage, we have to multiply it by 100. That becomes 2g plus 20g. That is summing up the denominator into 100. Simplifying, we get the answer as 10%. Next question, problem number 7. Calculate the molarity of sodium hydroxide NaOH in the solution prepared by dissolving 4 grams in enough water to form 250 ml of the solution. Please read the question once again. Calculate the molarity of NaOH in the solution prepared by dissolving its 4 gram in enough water to form 250 ml of the solution. Answer. Since molarity capital represented by the symbol capital M equals number of moles of solute divided by volume of solution in liters, that is equal to mass of NaOH by molar mass of NaOH divided by 0.250 liters of water. Therefore, it is 4G by 40G divided by 0.25 liter, that is equal to 0.1 mole divided by 0.250 liters, that is equal to 0.4 per mole, that can be written as 0.4 m. Please note that the molarity of a solution depends upon temperature because volume of a solution is temperature dependent. Next question. The density of 3m solution of NaCl is 1.25 grams per milliliter. Calculate the molality. Please note molality of the solution. Now we will solve it. M is equal to 3 mole per liter. Mass of NaCl in 1 liter of solution equals 3 into 58.5, that is equal to 17.5 grams. Mass of 1 liter solution equals the 1000 into 1.25, that is equal to 1250 grams. This is calculated from the relation the given value density is equal to 1.25 grams. It is given the density per milliliter. The density is given. Mass of water in solution therefore is equal to 1250 minus 75.5. That is equal to 1074.5 grams. Now we will recall that molality is equal to number of molecules of solute divided by mass of solvent in kg. That becomes 3 mole divided by 1.0745 kg. That is equal to 2.79 m. That is molality is small m. Often in a chemistry laboratory, a solution of a desired concentration is prepared by diluting solution of known higher concentration. The solution of higher concentration is also known as Stock solution. Note that the molality of a solution does not change with temperature, since mass remains unaffected with temperature. That means mass does not depend upon the temperature, whereas volume, that is associated with molarity, depends on temperature. Molality does not depend. Next, we will take up multiple choice questions. Question number 1. What is the mass of carbon dioxide which contains the same number of molecules as are contained in 40 grams of oxygen? That means we have to calculate the mass of carbon dioxide which contains the same number of molecules as are contained in 40 grams of oxygen. You are given 4 options. Please read these 4 options. A 40 grams, B 55 grams, C 32 grams and D 42 grams. Now you have to calculate the mass of carbon dioxide. Let us analyze the question. So mass of oxygen is equal to 6.023 into 10 to the power of 23. 32 grams of oxygen is equal to 6.023 into 10 to the power of 23 molecules. Therefore, 40 grams of oxygen contains 40 into 6.023 into 10 to the power of 23 divided by 32. That is 32 grams of oxygen. That is equal to 7.529 into 10 to the power of 23. Therefore, mass of 6.023 into 10 to the power of 23 molecules of carbon dioxide gives 44 gram. Therefore, mass of 7.529 into 10 to the power of 23 molecules of carbon dioxide gives 44 into 7.529 into 10 to the power of 23 divided by 6.023 into 10 to the power of 23. That is equal to 55 grams. So the correct answer is 55 grams, which is given in option B. Please mark it. The next question. The number of oxygen atoms present in 1 mole of oxalic acid dihydrate is, you are given 4 options. We have to analyze and mark the correct answer and choose the correct answer. So let us do analysis. 1 mole of oxalic acid dihydrate, whose formula is COOH subscripts 2 into 2H2O, contains 6 oxygen atoms. 2 here and 2 into 2, 4 plus 2 into 2O here. So 6 atoms. Number of oxygen atoms in 1 mole is 6 into 6.023 into 10 to the power of 23. That is equal to 36 into 23 atoms. This is given as option D. Please mark it. Next question. The density of gas in 1.78 grams per liter at STP. The density of gas is 1.78 grams per liter at STP. The weight of 1 mole of gas is, you are given 4 options. You have to analyze and mark the correct answer. 1 mole occupies a volume of 22.4 liters at STP. The mass of 1 mole of a gas equals density into multiplied by volume, that is equal to 1.78 into 22.4, that is equal to 39.9 grams. This is given as option A. Please mark it. Next question. Which of the following gases will have least volume if 10 grams of each gas is taken at the same temperature and pressure? You are given 4 choices. Please read it and let us analyze it. Number of moles equals 1 over molecular mass, that is molecular mass of carbon dioxide is equal to 44 and molecular mass of nitrogen is 28 and that of methane is 16 as well as HCl equals 36.5. Carbon dioxide will have least volume. So, as number of moles is directly proportional to the volume at constant pressure and temperature. So, mark it. Carbon dioxide will have the least volume. Please mark it. Next question. 0.48 grams of a sample of a compound containing boron and oxygen contains 0.192 grams of boron and 0.288 grams of oxygen. What will be the percentage composition of the compound? So this question is about calculation of percentage composition. 4 options are given. So you please read all the 4 options and we will analyze. So percentage of boron is equal to 0.192 grams because weight of boron is 0.192 grams divided by the weight of the sample, that is equal to 0.192 divided by 0.48 into 100 because of the percentage, that comes to 40%. Similarly, we can calculate for percentage of oxygen, that is equal to 0.288 divided by 0.48 into 100. That simplifying becomes 60%. So boron is 40% and oxygen is 60%. So the correct answer is B. Please mark it. Next question. A compound contains two elements X and Y in the ratio of 50% each. Atomic mass of X is 20 and Y is 40. What can be its simplest formula? This question is about writing the simplest formula. So 4 options are given. Now we have to analyze and mark the correct answer. Percentage element of X is given as 50. Therefore, the mole ratio is 50 by 20. That is equal to 2.5. Percentage element of Y equals 50 and mole ratio is 50 by 40. That is equal to 1.25. Hence, Y is 1.25 and X is 2.5. So, the formula will be x2 and y1. This is given x2, y1 is given as option B. Next question. The relative number of atoms of elements X and Y in a compound is 0.25 and 0.5. The empirical formula of the compound is 4 options are given. You have to analyze and mark it. Relative numbers of mole X is equal to 0.25 divided by Na. Relative number of moles of Y is equal to 0.5 divided by Na. There where Na atom is equal to 1 mole. Mole ratio of X is equal to 0.25 divided by 0.25. That is equal to 1. Mole ratio of Y is equal to 0.5 divided by 0.25. That is equal to 2. Hence, empirical formula is XY2. This is available in option B. Please, sorry, it is option C, XY2. So, please mark C as the correct answer. Next question, 8. The empirical formula of a compound is CH2O2. What would be its molecular formula? Four options are given and you have to choose the correct answer. Let us analyze and then choose. So, empirical formula multiplied by N gives the molecular formula. Therefore, the given compound CH2O2 subscripts N, where N is equal to 1, 2, 3. Hence, among the given option, CH2O2 will give C2H4O4. So, please mark the answer as C2. C2H2O4. Next question. 2.82 grams of glucose is dissolved in 30 grams of water. The mole fraction of glucose in the solution is. Four options are given. You have to analyze and write. Analysis is given in the insert table, and as per the calculations given in insert table, option A is the correct answer. Please mark it. Next question. The final molarity of a solution made by mixing 50 ml of 0.5 capital M HCl, 150 ml of 0.25 HCl and water to make a volume 250 milliliter is. Please read the question again and mark the correct answer given in the option table. So let us analyze. M1V1 is equal to M1V1 plus M2V2 is equal to MV. Therefore, M1 is given as 0.5 into 50 milliliter. It is given plus 0.25 of HCl into 150 ml of HCl. That equal to combination gives the product M into 250. So, from this equation, we can calculate M value of N as 0.25. This answer is given as option D. Next question. 4.28 grams of NaOH is dissolved in water and the solution is made to 250 cc. What will be the molarity of this solution? Four options are given. You have to mark the correct answer. So, let us do it in the insert table as given in the insert table. Number of moles of NaOH is 4.28 grams. That is the weight of NaOH divided by 40. That is molecular weight. That is equal to 0.107. So, volume of solution is equal to 250 centimeter cube. It is given. That is Cc is converted into Cm to the power of 3. Therefore, M will be is equal to N divided by V. That is equal to 0.107 divided by 250 into 1000. That is equal to 0.428 moles per liter. This answer is given as B. Please mark it. The last and final question is, which mode of concentration does not change with temperature? So you have to remember it. So there are four options given: molarity, normality, molality, and all of these. So you have to remember only molality does not change with temperature. Please mark it. Thus, we come to the conclusion of stoichiometry and stoichiometric calculations. In the next class, we will start Unit 2, Part 1. Till then, goodbye.